Hello, I'm Christian Wangier. This is my final project for E90. My topic is Google Container Engine, pets versus cattle. If you're wondering what animals have to do with cloud computing, well, congratulations, you're in the right place. So sit back and relax. By way of agenda, I'll be giving a brief intro to the Google Container Engine and a quick overview of Google's other cloud offerings. We'll make the case for the containers and see how Google Container Engine helps us manage containers. Finally, we'll go through a demo of an application that I have put together to illustrate Google's offering in the container management space. As you may already suspect, Google is a major cloud provider and as such is a formidable competitor to both AWS and Microsoft Azure. This is their offering dashboard. As you can see, they have a slew of services. All you need to get started is a Google account and a credit card, and you're in business. I must say that their sign-up process was a bit arduous. It took me about a week to get going. They too offer a free trial period of 30 days or $30 or $300 worth of service credit. We're going to be focused on the container engine service. Google Container Engine, abbreviated GKE, is Google's offering for running containers, for running Docker containers. It's really a combination of three services: Google Compute, which is also exists as a standalone service similar to AWS instances which we've used. The second component is a private Docker repository so you can store Docker images. And the third is a container management, which is really the secret sauce of the service here. Google says that they've been using the same technology to run all of their services, from Gmail to Google Voice to Gmaps. Apparently, everything at Google runs in a managed container. According to their numbers, they launch approximately 4 billion containers a week. Before we delve in too deep, let's take 2 seconds to contextualize the discussion here about computing with containers. At a very high level, the focus of the computing industry has evolved from mainframe servers down to personal computers and now back to the cloud. In a way, we've gone full circle from centralized, large-scale distributed computing to smaller devices and back now to large-scale computing, large-scale distributed computing services. We have spent a lot of time discussing cloud service providers. However, we must not forget that the demand for cloud services is really driven by consumers' appetite for immediate and adaptive services delivered on a variety of platforms. Indeed, the mantra is common that consumers want what they want, when they want it, and how they want it. To respond to these modern demands, businesses have to be responsive and nimble. It is not sufficient to just get into the cloud. Businesses have to be flexible within the cloud. We will see how Google's container engine moves us a step closer towards nimbleness and flexibility. So about the animal analogy, how are cats different from cattle? Well, the difference is in the way we think about them and how we treat them. We cuddle pets, give them names, and give them individualized attention. On the other hand, we treat cattle in a much more agnostic manner. Here, for example, a particular animal in the herd is just identified by a number. Google's pitch to their consumers with GKE is that Google is the best in the business at running large-scale servers. Google wants you to treat your application servers like cattle rather than pets. Simply declare your desired herd size and let Googlers tend to your cattle so that you can focus on your core business rather than dealing with server instances. So why containers? Well, let's review a few of the benefits of containerization. Number one, and probably the most significant one, is the isolation of environments. So remember when we were building Java applications, we would worry about what version is installed in our build environment versus what version is running in an environment where we're going to deploy that application. In our case, in deploying in AWS. Containers address this concern. The second benefit of containers is portability, the idea that you can, once you've built a container, you can carry it with you and run the application anywhere. So for example, you could run an application on-prem and migrate that same container without changing the code and run it in the cloud. Number three is scaling. So this is the idea of running multiple containers without them interfering with each other and thereby letting you easily stack services on one machine and thereby maximizing utilization. At a high level, the process of getting your application to the GKE platform looks like this. Step one is to containerize your application. Step two would be to declare your infrastructure, how big you want your cluster to be. And number three would be to deploy the containers using a Google hosted container orchestration device that is on GKE. This makes it easy to instantiate and replicate containers. Google makes it easier to build Dockerized containers by providing instances that already have Docker installed. They also provide a slew of CLI tools to help building containers. Now that you have probably warmed up to the idea that you should containerize, but you're still anxious because you remember how difficult it was to deploy and manage containers. For example, the whole idea of mapping ports or finding containers that are running just seems unattractive. However, those pain points arise when we treat containers as pets to be coddled. Google's container engine takes away that very concern of managing containers. So meet Kubernetes, the container manager or orchestrator, if you like. Kubernetes is like a Maasai warrior who you hire to watch over your cattle. Remember that we want to own cattle, not pets. Kubernetes is an open source platform that allows us to deploy containers and treat a cluster of machines as a single machine. In Kubernetes, you simply declare the cluster size, that is the number of machines you want to run, and the optimum number of containers or pods that you want to run on those machines. Kubernetes will then automatically manage the containers by replacing faulty containers or by, say, assigning IP addresses to a group of, say, 50 containerized web applications. Being an open source platform, you can actually install Kubernetes as a standalone product in your data center. However, Google has done this work for you in a hosted Kubernetes service, and this is what they call the Google Container Engine. Now, to demo Google's offering, I've put together a cross-platform application in a master worker arrangement, very similar to what we saw with MapReduce and the Monte Carlo simulation examples. On the left-hand side, you have a producer generating work and pushing it to an AWS queue. On the right, there's a master who manages the workers, getting work from the queue and completing the work. In this illustration, the workers represent a containerized application running on a cluster managed by the Google Container Engine. So to demonstrate the benefits of Kubernetes and GKE at large, I'm first going to run the container without Kubernetes and show how difficult it is to manage the container. Then second, I'll run the container with Kubernetes and show the scaling of containers on a single machine. In the third the third example, I will run the container with Kubernetes and turn on auto-scaling within GKE's cluster manager. So let's get started. So for part one of the demo, I will be running containers from a Google instance to consume these messages that are showing up in the AWS queue. So this is my queue on the AWS side. This should look familiar. My message count. And let's go over to the Google Compute side. I have an instance running here that I'm going to use to manage my cluster in the next example. But for this example, I'm going to this instance has Docker images on it, so I'm going to run those images. I'm going to run those containers from this instance and consume messages from AWS. And the point is to show this machine getting stressed by the containers that we build on that machine. So here we go. Connecting to the instance. So I'm connected to the Google Compute instance. Let's check our Docker images. Oops, Docker images. All right, I'm going to increase the screen size so that we can see it a little bit better. Okay. And we're going to run one of these images. And we're showing the image consuming messages from the Amazon AWS queue. So what I'm going to do is create a few more containers on this machine and show the machine getting stressed. So let's first check how much memory we have. Okay. Memory utilization is at about 10%, 20%, 15%. So let's see if we can stress this a little bit more. So created one container, 2, 3, 4, 5. Let's check the memory. Okay, we are up to about 40%. Let's keep going. I'm going to create 10 containers on here. Oh, I can tell the machine is slowing down. Let's check how much memory we have. We've used about 80%. Let's a few more, 2 more. Okay. So let's not go too far or else our machine will become unavailable. So these are the running containers. And if we go back to the AWS side, we can see messages falling off the queue. 519, 513, 509. So those containers consume messages at about one message every 4 seconds. And so with 10 containers, it's about 5 messages a second. Now we saw our memory utilization climb sort of high with these containers running on the system. You can see this is probably about about 80% memory utilization. So this is a production server and you wanted to manage these containers. It'll be difficult to manage. This is the point. Without a synchronized service for running the containers. So what I'm going to do next is I'm going to kill all these containers and recreate them with a Kubernetes replication cluster that manages the containers for us. So stopping all containers. Okay, screen cleared. The next example. Okay, example 2, we're going to demonstrate make the case for Kubernetes container manager. So we're back in AWS. This is our queue. We have 11,270 messages, and we can see the messages are not being consumed. We go over to the Google Container Engine. This is my defined cluster. A cluster is a number of machines that are a group of machines that Kubernetes is going to use to run my containers. So this is the Google Container Engine. If we go over to the Compute Engine, you will see my 2 instances that are part of the cluster listed here. And this is the one instance that I use that has my tools installed that I'm going to use to run Kubernetes on. Okay, so let's get started. So there's nothing running as we saw on the queue side. There are no messages leaving the queue. And if we come back here and we check get pods. There's nothing running, all right? So we're going to create a container using the same Docker image that we used the first time. And there are our Docker images. And so here's the command to create containers and using a replication controller in Kubernetes. So we've created one container, and for simplicity's sake, my pod only has one container, and we can do get pods to see what's running. And there you go. It's one container running. If we check the queue, messages should now be leaving the queue slowly but surely. 262, 261. So about every 4 seconds, a message leaves the queue. Okay, so that's too slow. Let's scale this up, speed it up. And here's the command to, and this is the command to scale up the number of containers or pods running. When I use pods and containers to mean the same thing, although they're not. A pod is a collection of containers, but my pod only has one container for simplicity's sake. So I'm just going to be saying container, but I really mean pod. Or if I say pod, I mean a pod, a collection of containers. So let's go crazy. Let's scale to 25 pods. And we can see that the replication container has been scaled. So if we check how many pods are running, we have a lot of pending. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, about 12 pods running. So let's give it a second and see if more of them will be instantiated. Let's give it 20 seconds. So how come not more of these pods are not running? Well, if we remember last time we ran the pods without the controller, our machine got stressed. So let's look at the machines that the pods are running on and see how they're doing. So I'm just SSHing to one of the machines that is in the cluster. And I'm just going to do very simple free m to see the amount of memory. And you can see that this machine is pretty much at capacity. So the replication controller knows that the machine is distressed and therefore is not scheduling any more containers on that machine. And in this case, our cluster is very small. It only has 2 small machines, and that's why our pods remain in a pending state. So if you check pods again, you see lots of some running pods, but a lot of them are pending. So in this case, we have vertically scaled by increasing the number of pods running on a machine safely without bringing the machine down because the replication controller knows the capacity of the cluster. So the next step would be to allow auto scaling in our cluster so that if we need more containers, then our cluster is configured to have that cluster can automatically scale. So let's go ahead and turn on auto scaling on our cluster. So here we go back to Google, the console, and we go back to the container engine. Here we find our defined cluster, click on it, and we're just going to edit the cluster. We're going to turn on auto scaling, and we're going to say go to a maximum of 6 instances. And we save that. And since we have pending pods, let's just check on them and see how they're doing. So let's say get pods again. And we still have them pending. So let's try to scale Let's try to scale again. We're scaling the replication controller to 25, and let's see what happens on the compute side. So as you can see, more instances are coming up. So since we scaled our replication controllers, you can see more machines came online now to match what we described in our autoscaler. So we have 1, 2, 3, 4, 5, 6 machines running, and let's look at what we defined in the cluster. Back to container engine, and our cluster has a size of 6. And so since we scheduled a lot of pods, not a lot of memory, those machines are basically running at capacity, and that's why we're at the maximum size of the cluster. So that demonstrates auto scaling from the cluster. So what we saw in this example is both vertical scaling with the number of machines on one instance, and horizontal scaling with using Google Compute Engine or Google Cluster Engine, Google Container Engine to define a cluster, container engine, to define a cluster and define a scaling policy for that cluster so that as it gets requests for work, the cluster can grow. So this is a very nice application of container management and makes working with containers quite easy, or at least a lot more manageable than it would be without a container manager. I'm going to clean up now by deleting all my pods, and to do that, I simply delete my replication controller, which I know is called Simba. And all the pods that I created previously will slowly die off. If we do get pods here, we have actually killed all of them. There's nothing running. So that ends our demonstration, and thanks for watching.